this is question 7 in MA3A6 sheet 1, and it says let K be a number field and A1, A2 up to AR be a Q basis for K, which is this K. Prove that K is Q adjoin alpha 1 all the way to alpha R. Okay, so let's go through a few definitions first. So K is a field, right? So it's an abelian group with respect to addition and an abelian group with respect to multiplication, and it also has a multiplicative inverse. It's not particularly necessary to know that, but this is a Q basis, which means it's Q linearly independent. So if you scale these elements by Q, some of them, if you scale some of them by Q, not all of them, if you sum some of them by Q and add them together, so take a linear combination of some of them, you can't get the other ones, right? You can't make some of the AIs using linear combinations of other AIs. An easier way to say this is like if we have some B1, A1 plus B2, A2 and BR, alpha R equals 0, then all of these BIs are 0. Right? So they're Q linearly independent and they span K. So every element in K can be represented as something of this form, where the BIs are the rational numbers. Okay, so it says prove that K is Q adjoin alpha 1 up to alpha R, and this does look a bit difficult, like a difficult problem. It's actually fairly straightforward. The elements of this form, right, are going to be in Q adjoin A1 up to AR. So wait, before that, what is Q adjoin A1 up to AR? It's the smallest field containing A1 up to AR. So clearly the smallest field will have the element like this, right? Because it's closed into multiplication. So we can multiply by elements in Q to get something like this with A1 in each of them. And when we add, because we can add elements together in a field, then we get something of this form, right? So clearly K, elements in K are in Q adjoin alpha 1 up to alpha R. And so that's pretty easy, that direction. But what about the other way? What about how do we know the elements in here are in K? Well, we can do that in a kind of a roundabout way, because this is the smallest field containing all of these elements, right? And K, we know, is a field, and it contains all of these elements, right? This is a subset of K, because this is the smallest field that has that property, and K is a field that has that property. So we have that this is a subset of K. Okay, but now we've got the inclusion both ways. So the second part, just to clarify, is because Q adjoin A1 up to AR is defined to be the smallest field containing these elements, and it's actually well defined in that way, right? Because you can take intersections of two fields and get a smaller field. And so we have this, and now we're done. K equals Q adjoin A1 alpha R. Okay, so thanks for watching. That was pretty short.